Go to question 3. Now left the simplifying of sets. That shouldn't be a big issue. So go to question 3b. Let z be equal to, let z1 be 1 minus 2i, z2 be equal to 2 plus 3i, be complex numbers. 1, express z2 minus 1 over z1 in the form a plus ib, where a and b are real numbers. So of course, we already have z1 and z2. So I'll just substitute. So z2 is 2 plus 3i minus 1 over z1. z1 is 1 minus 2i. So we're keeping this one, waiting for the conjugation the other side. So multiplied by 1 plus 2i, 1 minus 2i, we multiply by 1 plus 2i. So that we have 2 plus 3i minus, on top there we'll have 1 plus 2i over 1 times 1, we get 1 plus 2i minus 2i. Negative times positive, we get minus, but I times I, we get negative 1 again, so it becomes positive 4. So now we have 2 plus 3i minus 1 plus 2i over, this is 0, 1 plus 4 is 5. This minus is for everything. So as we split these in fractions, we can even start by doing this 1 over 5 plus 2 over 5i, so that we get 2 plus 3i minus 1 over 5 minus 2 over 5i, which is 2 minus 1 over 5 plus 3i minus 2 over 5i. So you can add them separately now. So you get, this is over 1, so 5 as the common denominator. So you get 10 minus 1 plus this guy over 1, 5 as the common denominator. So 15i minus 2i, which is 9 over 5 plus 13i over 5. So the job is just to substitute. Where there is z2, you put the actual z2. z1, you put the actual z1. Like that.
Sir, I've got a question on complex numbers. Can I give it?
You have a question on
Complex numbers.
You are dictating.
The modulus of z. No, the modulus of z minus I.
Minus I.
Is equal to 2z minus 4i.
2z minus 4i.
They're saying find the complex numbers.
So first, inside here,
Yes.
you write it as x plus iy, that is z, and then you do the same on the right. Write x plus iy minus 4i. And then, by definition of this guy, you can say this is x plus y minus 1 I is equal to 2x plus y minus 4i. So I'm factoring out the i's. So this is the square root by definition of x squared plus y minus 1
So
squared.
why the bucket?
Oh yeah, 2y in the bracket. So this is equal to 2x plus 2y minus 4i. And then we square this side. We also have to square the other side. This is going to be x squared plus y squared minus 2y plus 1 is equal to 4x squared plus 2x 2y minus 4i plus 2y minus 4i by 2x plus 2y minus 4i squared. So it becomes x squared plus y squared minus 2y plus 1 is 4x squared plus 4xy yeah. So such questions, such questions are not solved. Last time I remember there was this question.
Yes.
Last time,
They are living.
they're not today. There was a question of this nature in some deferred test, and I was making the marking, so I was just told there was a mistake there. The examiner did not intend to have this Z on the right because it makes things complex. So I was just told you make the marking and you mark in any way that you feel like. I just cancelled it. So here, find x and y. So find x and y. Given that z1 and z2 are here. So the best thing you do here is you divide by z2. You divide by z2. This is too easy. This is equal to x plus iy, implying that x is equal to 2 and y is equal to 0. Yeah, done. My main interest is in this table here. My main interest is in this table here. I'll put it here.
So I'm kindly asking if you can explain on how we arrived to y is equals to 0.
Okay. So the table below shows an operation star on a set G is equal to 1, 5, 7, 11. And the table is star 1, 5, 7, 11. 1, 5, 7, 11. And then here you have 1, 5, 7, 11. 5, 7, 11. 1, 11, 7. 11, 7. 1, 5. 5, 1. Okay. How have you arrived at y is equal to 0? This z here has cancelled. This z here has cancelled. So we have 2 is equal to x plus iy. Now x is a constant. In z, you're supposed to have x plus iy. The y is the one that is being multiplied by I. The x is the one standing alone. So if we have that 2 is equal to x plus iy, you can as well write the left-hand side as 2 plus 0i is equal to x plus iy. So 2 is the one standing alone, so it is equal to x. And then since there's no I on the left, it means that its coefficient is 0. So then you conclude that y is equal to 0. Because if y was not
All
0,
right, sir.
okay. So now you have this structure here. Then question 1 is saying, is star a binary operation? Give a reason. Okay. So is it a binary? So you say yes. Because for every A and B in G, A star B is in G. What do I mean? G has numbers 1, 5, 7, 11. And this whole thing here, as you can see, we have 1, 5, 7, 11. 1, 5, 7, 11. All the numbers inside are 1, 5, 7, 11, 1, 5, 7, 11, 1, 5, 7, 11. So there's no number that is not in G. So all the numbers are in G. So it is binary. And that's the reason. For it to be binary, you just want that whatever you do to the numbers, you should still get a number that lies in the same set. Second is star commutative? So to be commutative, when you're given a set like this, you go to the numbers and you're reading 1 star 1 is equal to 1. 1 star 5 is equal to 5. So now we see if we get 1 star 5, we'll get 5. If we get 5 star 1. You know, starting with 5 star 1, you will still get 5. So this combination is okay. Let's go to 7 star 5. So we'll have 7 here, star 5. So we're getting 11. What about 5 star 7? So you come to 5 star 7. You're getting 11. So same. It is 11. Can try again. What about 11 star 7 and 7 star 11? So 11 star 7 is 5. So we get 5. What about 7 star 11? We're still getting 5. So it looks like all the combinations will be getting 5. So A, so you can see that from any choice, A star B will be the same as B star A. So star is commutative. Then you are being asked now to see if you know what you are doing. Evaluate 5 is star 1 and 5 is star 7. So this one, 5 star 7, star 7 star 11. Let's start with the top one. 5 is star 1. Start with 5, go to 1. This here is equal to 5. We are done. Then 5 is star 7. 5 star 7. We get 11. So we put 11 here. Star 7 star 11. 7 star 11. We're getting 5. So we put 5 here. And now do 11 star 5. So 11 star 5. We're getting 7. So 7 becomes our final solution.
So, sir, in that case, is it okay if you conclude that 5 star 7, then star 7 star 5, you star 11, you just get the number which is common?
Not where the star is concerned. This star here has no factorization.
Sir, me, I'm just concerned on the table. Let's say the way you started there, you did on the x-axis and the y-axis, and the second row and the second column you did the same, but on the third, how did you choose those numbers?
Why are you saying x-axis and y-axis?
Okay, the row in the column.
Exactly.
So in case like column 1 and column row number 1, the values are the same. Some apply to column 2 and column 3, but on the third column, on the first row.
I did not generate this table. This table was generated by the examiner.
Or was given?
Yes.
All right, thank you.
So you are answering based on what you are given.
I thought you generated it.
You don't generate tables. You just answer using these tables. Okay, so now I can basically say that before I basically say that is something that is nice here. The table. Solve for x and y are given 1 plus I squared is equal to 3 plus 2I over x plus IY. The mistake that most of us would want to make here is to cross multiply and expand everything. That's a serious mistake. What we do is we take our time, we get 1 plus I squared and evaluate it. This is 1 plus I multiplied by 1 plus I, which is 1 plus I minus 1, which is 2I. So we have 2I is equal to 3 plus 2I over x plus IY over 1. Cross multiply. 2I, don't expand this. Just keep it here. The question says solve for x and y. So divide anything which is not x and y. What we mean with x plus IY is equal to 3 plus 2I over 2I. Then conjugate. So you're multiplying by negative 2I. You're multiplying by negative 2I. So you have 3 by negative 2I. That is negative 6I. I times I get negative 1. Negative 1 times negative 4, we get positive 4 over negative 4I squared, which is negative 1. So we have 4 minus 6I over positive 4, which is 4 over 4 minus 6 over 4I. That is 1 minus 3 over 2I. So x is 1, y is 3 over 2, which is negative.
Sir,
Hello.
on the part where we have conjugated, can we use what you told us in the next class, in the last class, sorry, where you said we can, instead of conjugating, we can multiply both parts by I. Is it also applicable in this case?
Very much applicable.
All right.
So I just did this to avoid so much concepts to be memorized. Okay. Why should you expand? If you try to expand and see. It becomes very, very complicated at times. Especially when the denominator does not come out to be 2I, it comes out to maybe 7 plus 15I. When you expand, you're going to have equation, then it will be too long for you to get the solution. Sometimes it even fails to come out. So Zambia is playing against Tunisia at 21 hours. You can as well support as you cool down from this learning. Have a good night.
Thank you, sir. Good night.